Hi guys, so now we talk about the traversal. Traversal is one of the operation or right. We discussed about 5 operations of binary trees. So insertion has been discussed in the previous video. So in this video we discuss about the traversal. So traversing is a method of visiting each node of a tree exactly once in a systematic order that has been mentioned, or else that order has been given. So during traversal we also print the information field of the each node that is visited. Okay, so when we look over the figure, we can find that there are various techniques for binary tree to traverse a binary tree. So there are 3 ways that how we can traverse a binary tree. First one is pre-order, second one is in order, and third one is post order. So let us look over what is pre-order traversal. So pre-order traversal of a binary tree can be recursively defined as first point, the process the root node. First we need to check out the root node, we need to process it. Then second point, traverse the left subtree of the pre-order, that is we can denote as L. Then thirdly, traverse the right subtree in pre-order, right? So here the second and the third steps will be recursively calling the function back, until all the nodes are being traversed, all the nodes are being visited, right? So it is something like root node first, next is the left subtree, then there's right subtree. So pre-order in the sense we will concentrate on, or else we will make the root node to be the base, and if it is a pre-order means at the first. Okay, so root node will be at the first, next will be the left subtree, and then the right subtree. Okay, so here is a simple function that will help us to understand how to display the contents in a tree in a pre-order, that is to traverse the contents of a tree in a pre-order. So here you can see the example 10.4.1.2 that helps us to understand the function of displaying the contents in pre-order. So at the beside you can see the diagram wherein the darkened node is the root node, and L denotes the left subtree and R denotes the right subtree. So the declaration is like pre-order with the node root. We start with the root node. So first we will visit the root node, so that's why we will go for the if statement. So if root node is equal to null, that means if the tree doesn't exist or else it is an empty tree, then return nothing. So other than that, printf the root node, the information whatever present in the root node. Then go for the left link of the root, or else you can say the left subtree of the root. In again we are recursively calling the function back. So again in the left subtree there will be again the root node, left subtree of that subtree, and then right subtree of that subtree. Then after that we will go for the right link of the root node, that is again we are going to recursively call the function. So this function will be recursively called again and again until and unless all the nodes are been traversed in pre-order. So thing to be remembered in pre-order is that first a root node will appear, then a left subtree, then the right subtree, right? And now we will go for the in-order traversal. So in the in-order traversal, the binary tree can be recursively defined as first. So in-order means the root node has to be at the middle. So before the first we will go for the traversing the left subtree in the in-order way. Then second point we process the root node. Then third we go for the traversing of the right subtree in the in-order way. So these first and third point will be recursively called, and in the middle we go for the processing the root node, right? So in order means in between, pre-order means before. Okay, so in pre-order the root node will be appearing at the first, before, then left subtree, then right subtree. In the in order, first we will go for the left subtree, then the root node, and then lastly the right subtree. So the figure below helps us to write the C function to traverse a tree in order way, right? So let us see the function. So this is the function to traverse the tree in order. So in order, again we are going with the root node. So first we will check whether the tree exists or not. So we will check the condition if root is equal to null. If that is equal to null, then return nothing, or otherwise first go for the left subtree, then go for the middle, that is the root node. We will print the information of the root, then lastly we will go for the right subtree, right. Next traversing, we discuss about the post order. In the post order traversal of the binary tree, we call recursively the following steps. First we will go for the left subtree, then we will go for the right subtree, lastly we will process the root node. Post means at the last, so root node will be processed at the last. So first will be the left subtree, second will be the right subtree, then root node will be at the last. You can see the diagram how it indicates the traversing method. So based on the diagram we can write the function in the following way. So the declaration preorder, so the parameter being passed is the root node. So here first we will check about if the if the tree is existing by checking that root is equal to null. If it is so, then return nothing, or else go for the post order traversal. First the left subtree, then the right subtree, and lastly the root node. So here is a simple example that I have designed to understand the traversing on the preorder. So this is the tree wherein we have 9 nodes that are being arranged in the binary tree format. Okay, so how we can do in the preorder means the root node will be appearing at the first, so and the left subtree and the right subtree will be called recursively. So better going for directly to the root node, make the problem to be evaluated in a simple manner. So go for first the small subtrees and then go for the bigger one. So just I made the small subtree marked with the small rectangular boxes, and then the bigger one, and then lastly the root node. So the above tree can be written as, first we will process the small rectangles. So in the left part where D is the node and G and H are the left subtree and the right subtree respectively. So since it is preorder, so D will be written first. D will be written first. Let me mark that with the pen. Wait. So you can see here D is the root node here for the subtree, G is the left and H is the right. So when I start processing, so it is since it is preorder, so D will be the first, then second will be G, and then third will be H, right? So same thing I wrote here. So D, G, H. So out of this, at the first step we'll get D, G, H, then go for the right subtree. So here again I have a small tree available here. So first we will go to the preorder in the sense first E will be printed, then left since it is null, so we'll go to the right subtree, so it is I, so EI will be the result. And here since only one node is available, so I am going to write F as it is. Okay, so further I am going to write in a simplified way. So it will be DGH, what here it is been written DGH, and then since this node is again empty, it is null, so in this so left, since it is a preorder, B will appear first, then we will go for the left and then right. So B will be written here as it is, then DGH next. Since it is null, I am going to write nothing here. Then in the right part, so since it is preorder, first we will write the C, so C, then EI at the left, and then F at the last, right? Okay. Further, this can be simplified in more simpler form. So we have previously got BDGH at the left subtree and CEIF at the right subtree. So now, since it's a pre-order, first go for A. So A has been written, then go for the left subtree, so BDGH, and then go for the right subtree, so CEIF, right? So here is a description what I did. Easiest method of writing pre-order traversal is to start from the innermost square and visit each node in the sequence specified as shown in these diagrams. So this is the way how we can go for a pre-order. So here I am taking the same diagram of the tree and I am applying the Inorder. So here again I am simplifying the tree within the smaller subtrees so that I can apply the Inorder technique. So let me go for it. So Inorder means from left, then root node, and then the right. So left G, then root node D, and then H. Okay, so here it was a little bit of spelling mistake, so I made it as H is final, right? So when we look at the right, so since left no root node is available, it will be null, so we'll go for E, and then lastly the right part, right? Then since it is nothing available, no leaf nodes are available, no children are available, so I'm going to write F directly. This further can be written like this. So it is GDH what I got previously, and then EI, and then lastly F. So again this can be written in a in order way. So it will be GDH left subtree, and then root node, then B, then right subtree. Since right it is null, so I am going to write nothing here. So come to the right subtree here. So here EI was been resulted before, so EI will be displayed first, then it, since it is in order, so root node C, then lastly F. Okay, so further this tree can be simplified in this manner. So since it is in order, first we will go for the left part, so it will be GDHB, then the root node A, and then lastly the right subtree, so EICF. So this will be the in order traversal. So here I have written again the statements how we can do with this. Easiest method of writing in order traversal is to start from the innermost square and then visit each node in the sequence specified as shown in the figures whatever I have given. So same figure I am applying for the post order also. So the same figure I am applying for the post order. As before, I am going to simplify I am going to take the subtrees first. So since it is post order in the sense, first it will be left subtree, then right subtree, then lastly the root node. So G is the left subtree, so G, then right subtree H, then lastly it will be the root node. So it is D here. So when we compare here, left subtree is null, so it will be not been considered, then I as a right subtree, and lastly the root node, so E. So as it is a single node available, so I will write F as it is. This can be further simplified in this way. So we got a GHD in the previous, so I am making it as a one node, and right it is having null. So since it is a post order, first we go for the left, then right, and then root. So GHD left, since it is null I am going to write nothing, then lastly it is the root node. Same thing will be conducted at the right sub part. So IE was related to the previous, so IE will be taken. So since it is a post order, first left, then right, and then IE, then F, then lastly. This can be further simplified in this figure. So where GHD was the resulting node of the left subtree, IEFC was the resulting at the right subtree. So this again, when I apply post order again recursively, so since it will be left, right and root node, so left GHDB, then right IEFC and then A. So this is how we go for the post order traversal. Same statements are being written again here to make you understand more in a more easiest way. So easiest method of writing the post order traversal is to start from innermost square and visit each node in the sequence specified as shown in the figure. Right. So right, that was regarding the traversing technique in the binary tree. Next we will talk about the expression trees, one of the type of the binary tree, in the next video.